Good day. We are the Group 4 and we're here to present you our info video presentation entitled An Awareness of Anthropogenic Effects Toward the Environment, Flora, Biogeochemical Cycle, Nitrogen, and Sulfur. So, what is sulfur cycle? Sulfur is one of the components that make up proteins and vitamins. Proteins consist of amino acids that contain sulfur atoms. Sulfur is important for the functioning of proteins and enzymes in plants, and in animals that depend upon plants for sulfur. Plants absorb sulfur when it is dissolved in water. Animals consume these plants so that they take up enough sulfur to maintain their health. The positive impact of sulfur to plants. Sulfur supports several different plant functions like the formation of enzymes. Sulfur is also a crucial part of the process that creates new proteins in plants, which affects growth and vitality. Part of how sulfur interacts with plants involves being a catalyst of photosynthesis, which will be important to know when diagnosing a sulfur deficiency. The positive impact of sulfur to humans. Sulfur is a mineral that is involved in many reactions in the human body, as well as being part of important substances, such as detoxifying and keeping the body free of toxins is one of its key purposes. It is a component of several vital chemicals in the body, including several vitamins and amino acids, including methionine and cysteine, as well as various hormones like insulin and glucagon. Sulfur has a lot of purpose in human body.
Hi, my name is Neil Augustine, and I will discuss about nitrogen cycle. First, what is a nitrogen cycle? The nitrogen cycle is a repeating cycle of processes during which nitrogen moves through both living and non-living organisms. Since nitrogen is applicable to different organisms such as humans, flowers, plants, and trees, it must change forms in order to move through the different parts of the cycle. Next, we'll talk about the positive impact of nitrogen cycle to its surroundings. First is that it can create proteins. Nitrogen is one of the most essential needs of living organisms for their blueprint, such as DNA and RNAs, through a process called nitrogen fixation. Lastly, it undergoes assimilation. Nitrogen assimilation is the formation of organic nitrogen compounds like amino acid from inorganic nitrogen compounds present in the environment. That is all, and that is why nitrogen cycle is important to organisms. Thank you.
Hi, on this part, we'll be discussing the negative anthropogenic effect of nitrogen on flora. In terrestrial ecosystem, nitrogen can result in nutritional imbalances in different types of plants. Like this image, and the modification to the health of the forest, and the decrease in biodiversity. Based on the previous studies, it has been determined that humans are disrupting the nitrogen cycle that is biologically accessible to the environment, which is rising as a result of burning of fossil fuels and the usage of nitrogen-based fertilizers. Human interference to the nitrogen cycle will increase the levels of greenhouse gases, nitrous oxide, and other not nitrogen oxides that can negatively contribute to the environment, which decreases the levels of different nutrients like calcium and potassium that are necessary for fertilizing the soil, waters in streams, and increase nitrogens in river and coastal waters where causes a variety of adverse effects.
Next, we have the negative anthropogenic effects of sulfur on flora and environment. So human activities have played a major role in altering the balance of the global sulfur cycle. The burning of large quantities of fossil fuels, especially from coal, releases larger amounts of hydrogen sulfide gas into the atmosphere. So as the rain falls through this gas, it creates the phenomenon known as the acid rain. So acid rain also removes minerals and nutrients from the soil that trees need to grow. At high elevations, acidic fog and clouds might strip nutrients from trees' foliage, leaving them with brown or dead leaves and needles. So plants are sensitive to sulfur dioxide and they are affected by it both directly and indirectly. So the direct effects may be acute or chronic depending on the duration and intensity of the exposure. So sulfur dioxide inhibits photosynthesis by disrupting the photosynthetic mechanism. The opening of the stomata is promoted by sulfur dioxide, resulting in an excessive loss of water. The cumulative effect of sulfurous solution is to reduce the quantity and quality of plant yield. Generally, its impact is more severe when in combination with other pollutants such as oxides of nitrogen, fluorides, and ozone. At the ecosystem level, sulfur dioxide affects species composition by eliminating more sensitive species.
I am Gabriel Mari, and I am here to present the reduction of anthropogenic nitrogen and sulfur emissions in plants. So, the presence of nitrogen and sulfur in plants are significant for their survival. These elements are important in the role of plant metabolism and plant fertilization. However, excessive presence of these elements is highly detrimental to the environment. As said by my other group mates, most of the anthropogenic sources of nitrogen and sulfur come from the air pollution produced for human consumption. Once these elements are introduced to the atmosphere, it becomes acidifying pollutants that are the leading cause of acid rains, which can affect vast areas of water, grasslands, forests, and other ecosystems. So, how do you reduce the sulfur and nitrogen emissions? Some ways to reduce anthropogenic sulfur and nitrogen emissions include 1. Using alternative coals that contain lesser amounts of sulfur. 2. Washing of coals used in coal power plants in order to reduce the amount of sulfur within it. 3. Incorporating equipment and technologies such as scrubbers, which can help lessen the release of sulfur dioxide gases from coal burning. And 4. Transitioning to renewable resources such as solar, wind, or thermal power. These sources of energy are able to lessen the emission of a variety of air pollutants, including sulfur and nitrogen, during energy production.